Hello everyone, in this video I'm going to discuss the example for vector. Find the Cartesian equation of a straight line, which passes through the point, we have the P, 5, 8 and negative 3, and is perpendicular to the plane, we have negative 3x plus with the 6y minus the z equals to 7. So, question asks us to find the Cartesian equation of a straight line. So the formula for the straight line will be vector of r equals to, we have the a plus with the t, v. So here we have the point, this one will be the direction. So kindly focus on the situation. They said we have the plane, then the line is perpendicular to the plane. So from here we have the point P, and then we have the direction, the normal, we have negative 3, 6 and negative 1. So kindly substitute into the situation. So we have the r, which is equals to the position vector, we have 5, 8 and negative 3. Plus we have the t, v, we have the normal direction, negative 3, 6 and negative 1. So this is what we have, the vector equation of a line. So next, r is equals to, we have 5 minus the 3t, continue, we have 8 plus it is 6t, then we have the situation negative 3 minus the t. So x is equals to 5 minus 3t, and then y is equals to 8 plus it's a 6t, then z we have negative 3, negative t. So here we have the parametric equation of a straight line. Next, Cartesian, we have the situation x minus the 5 over the negative 3 equals to y minus the 8 over the 6 equals to z plus with the 3 over the negative 1. So that is the Cartesian equation of the straight line L. Kindly refers to B. The straight line R, we have the situation given. So 3, negative 5 and 7. Plus we have the lambda with the direction negative 4, 6 and negative 2. So that is the straight line. They say intersect with the plane. So we have the plane 5x minus 4y plus with the 2z equals to 25 at the point C. Calculate the coordinate of the point C. So express the vector equation of a straight line in the form of parametric equation. So we have x is equals to 3 minus 4 lambda, y is equals to negative 5 plus with the 6 lambda, z will be equals to 7 minus the 2 lambda. So kindly substitute in this part into the equation of plane. So we have 5 bracket 3 minus 4 lambda minus 4 bracket, we have negative 5 plus with the 6 lambda, plus we have 2z, 7 minus 2 lambda, so equals to 25. So we have the 15 minus with the 20 lambda, we have the 20 minus the 24 lambda, we have the 14 minus the 4 lambda, minus the 25 equals to 0. So focus on the 15, we have the 35, we have the 49. Minus the 25, so we have the 24. Minus, we have negative 20, negative 44, negative 48. Equals to 0. So kindly rearrange the situation. 48 lambda equals to 24. So lambda is equals to 1 over the 2. So since lambda is 1 over 2, kindly substitute into this part. So we have the x, where we have 3 minus the 2. So x will be equals to 1. Y is equals to negative 5 plus with the 3. So y will be equals to negative 2. Z is equals to 7 minus the 1. So z will be equals to 6. So the coordinate of the C will be 1, negative 2 and 6. C. Find the acute angle between the straight line and the plane. So kindly express the situation where we have the Cartesian equation of a line into the vector equation of a line. So x minus the 2 over the 3 equals to y over the negative 4 equals to z plus the 3 over the 5. So x is equals to, we have 2 plus with the 3t. Then we have the y is equals to negative 4t. Z, we have the situation negative 3 plus with the 5t. Continue, we have r equals to, we have 2, 0, negative 3. Plus, we have the t multiplied with 3, negative 4 and 5. So that is the vector equation of a straight line. So here we have the direction, and here we have the position vector. Next, we have the equation of the plane. So where we have 2x plus the 3y minus the z equals to 12. So from here, we will have the normal vector, 2, 3, and negative 1. So for this part, we have the vector v, which is 3, negative 4, and 5, meaning that the direction. Next, kindly illustrate the situation. So let's say here we have the plane. Next, let's say here we have the line. And as we all know, here we have the direction. We name it as v1. 3, negative 4, and 5. Then, as usual, we have the plane. The plane consists of a normal line. So let's say here we have the normal line. So with the direction, n is equals to 2, 3, and negative 1. So meaning that from here, we have the angle theta. We have v1 dot with the n equals to magnitude of v1 multiplied with the magnitude of n. Then cos theta. Kindly substitute the situation. So here we have 3, negative 4, and 5. Then we have 2, 3, negative 1. Modulus of 9 plus the 16 plus the 25. Multiply with, we have 4 plus the 9 plus the 1 cos theta. So if we dot the situation, we have 6 and then negative 12, negative 5. So we have the square root of 50 multiplied with the square root of 14, then cos theta. So by referring to the situation, we have the cos theta equals to negative 11 over, we have the situation square root of 50 multiplied with the 14. So by referring to the calculator, we have the situation theta, which is equals to 114.57. So meaning that here will be the theta. So let's say we name the situation in here as a A. So next, in order to find the angle here A, so we have to make use of the situation 180 degree minus 114.57 degree, so which is equals to A. So the A will be equals to 65.43 degree. Continue. The question said find the acute angle between the straight line and the plane. So actually our main focus is over here. So as we all know, here we have the 90. So we name it as the B. So in order to find the B, we know that we have 180 degree minus the 90 degree minus the 65.43. So the B will be equals to 24.57 degree. Kindly refers to D. Given we have the PQR at the 3 point. So PQ, we have the situation 2, negative 4, and 7. Then we have the PR 1, 3, and negative 1. And the coordinate, we have the R 1, negative 3, and 5. Find the Cartesian equation of a plane that passes through the point PQR. So kindly find out the normal vector. So let's say we have the vector PQ cross with the vector PR. So we have I, J, and the K. So substitute 2, negative 4, and 7, 1, 3, and negative 1. So we have the I, J, plus with the K. So here we have the negative sign. So kindly close up the I. So we have 4, then we have the 21. Close up the J. So we have negative 2 and then 7. Close up the K, then we have 6 plus with the 4. So the normal vector would be, we have negative 17, then we have the 9, then we have the 10. So that is the normal vector. Next, in order to find the plane, so we have vector R dot with the vector N equals to vector A dot with the vector N. So kindly substitute the situation. So we have X, Y, Z dot with the negative 17, 9, and 10. Then A is the position vector of R. So we have 1, negative 3, and 5 dot with the negative 17, 9, and 10. So negative 17x plus with the 9y plus with the 10z equals to negative 17 minus 27 plus with the 50. So we have negative 17x plus with the 9y plus with the 10z, where we have equals to 6. So that is the Cartesian equation of a plane that passes through the point P, Q, R. Thank you so much for watching this video. If you think the video is useful, kindly consider to like, comment, share and subscribe.